This video is on dividing radicals. We've got a lot of steps here. First off, look for perfect squares, take the square root, always be on the lookout for that kind of no matter what type of problem you're doing. Divide and or reduce whatever you can, and similar to multiplication, it's the outside stuff with the other outside stuff, the inside stuff or the radicands with the other inside stuff. Simplify radicals as much as possible, and just be aware. I even made note of this. These are not in any particular order. You can do stuff as you notice it. There are times when you might notice a perfect square first. There are times when maybe you'll divide or reduce, and then afterwards you'll realize, oh, there's a perfect square. Or you'll not think you can do anything, you'll start simplifying radicals, and after you simplify, you'll realize, oh, now I could always divide or reduce what I have now. So the order is not particular. Just if you notice you can do one of these three things, do it. That's what you need to do. And then after you've done all of that, rationalize the denominator, then check again. And this rationalizing the denominator, I'm going to get into that. And then give it a look over and see if you can do any of these things anymore. Definitely want to pause and write that stuff down. Now, the next thing you need to know is these are the same thing. It doesn't matter which way it's written. These are totally the same. So, and I would treat them the same. I could just divide the 56 by the 7, no matter which way it's written, and get radical 8, and then simplify that. But there's also a long list of other ways I could have done this. I could have rationalized the denominator first. I could have factored out the 56 and simplified that piece first. I think this would be the easiest way to do it, but it's definitely not the only way. All right, let's have a look. I don't see any perfect squares, but I notice that my 60 and my 2 are both radicands. They're both under the radical. It doesn't matter if they're two separate ones or one big one. So I'm just going to divide, and I've got radical 15. And I might try to simplify that. I'd get a 5 and a 3. No pairs. Radical 15 is just my answer for that one. Yeah, they won't all be that easy. Okay, now this one, 72 over 8. You know, there's a list of things I could do first. I could factor out the 72. I could also factor out the 8, but I also know that 72 divided by 8 is a whole number. That's 9, so I'm just going to switch to radical 9. Hey, look, perfect square. Square root of 9 is 3. They won't all be this easy. Okay. Now I've got 4 over 16. They're both radicands. I've got options. The first thing that sticks out to me is the fact that these are both perfect squares. So without dividing or anything, I could do the square root of 4 is 2 and the square root of 16 is 4. That reduces to 1/2. Just kind of a side note, I could reduce the 4 over 16 while they're still under the radical. And that would give me 1 over 4. Well, the square root of 1 is 1. The square root of 4 is 2. Notice these actually are both the same number of steps. So whatever you notice first, do that. All right. Same thing here, you know, 4 over 144, I could reduce that fraction, but I also know off the top of my head that the square root of 4 is 2 and the square root of 144 is 12. So noticing that they're both even, I can turn this into 1 over 6 and be done. I'm going to skip ahead a little. And I'm going to start looking at these. Definitely have this stuff in your notes, okay? Now, we cannot leave a radical on the bottom of the fraction as part of my final answer. So notice I can't reduce those, I can't simplify them, I can't take the square root. There's nothing else I can do, but I have to rationalize it. It means the thing down here, this radical 7, it's not rational, and I have to fix it. Now, I do that by multiplying it by itself. So on the bottom, I'm going to multiply that radical 7 by another radical 7. What that does is it cancels out the radical. Now I have just the 7, no radical. But the way that fractions work, anything that I do on the top, or anything that I do on the bottom, I have to do the same exact thing on the top. So on the top, I now have radical 42. Now 42, well, that's not going to do me a lot of good, right? Because that's a 6 and a 7, a 6 is a 3 and a 2. There's no matching pairs, so actually that's as simplified as we can get. Let's try just a few more where we have to rationalize that denominator. Okay, once again, the 81 is outside of the radical, the 3 is a radicand. There's nothing else I can do, but I have to rationalize that denominator. I have to get rid of the radical that's on the bottom. Now, that means I can multiply the top by the same thing, and now I have 81 radical 3 on the top. Now, the 81 and the 3 on the bottom are both outside of the radical. The 3 on top is a radicand. It just so happens that 81 divided by 3 is a thing. That's what, 27? And then the radical 3, well, there was nothing I could do with that. So see, after I rationalized the denominator, I had to check those other steps again because it created something else that I could divide or reduce. All right, let's do another one. Okay, I've got options here. I'll maybe do this one a couple different ways. This is our last problem for this video. So I have options. I cannot simplify the radical 10. I cannot simplify the radical 5. I could always rationalize the denominator. So that would give me radical 50 over 10. And then I could factor out the 50, right? Because that's a 25 and a 2. A 25 is a 5 and a 5. So I have a pair of 5s and a lonely 2. So that gives me 5 radical 2 on top over 10. 5 over 10 is 1 over 2, 1 radical 2 over 2, and that would be my final answer. That wasn't the only way I could do this. I could simplify first. This is 1 over 2. Let me switch colors maybe. So knowing that the 5 and the 10 are both radicands, I could simplify those and make it radical 1 over radical 2. Because 5 over 10 reduces to 1 over 2. And then the square root of 1 is 1. And I could rationalize the denominator by multiplying top and bottom both by radical 2, which gives me, look, 1 times radical 2 on top. And the radicals cancel out, and I have just a 2 on the bottom. Same thing, right? So it's kind of a matter of what you recognize first, just do that. And that is it for this video.